Here we go, guys. Last question of the day. Number 6. In the United States, whole milk consumption was 103 quarts annually per person in 1970 and fell by 3 quarts per person each year for the next 20 years. By contrast, low-fat milk consumption was only 25 quarts annually per person in 1970, but rose 2 and 2,500 quarts per person each year for the next 20 years. We'll let X represent the year X equals 0 corresponding to 1970. So we'll say like 1970 was year 0, and we'll just kind of increase from there. So it says write a linear function representing the consumption of whole milk. So then we come back up here, and it says whole milk consumption was 103 quarts annually per person in 1970. All right. So I could say for whole milk, W of X equals, all right, 103 quarts, and it fell 103 quarts annually. So 103 minus 3x. Okay, so it started out at 103 and it was being subtracted by 3 quarts per person each year. Okay, so we'll call that W of X. All right. Ooh, and then B says write the linear function representing the consumption of low-fat milk. So then low-fat milk was only 25 quarts annually per person in 1970, but rose 2 and 2,500 quarts per year. So then call this L of X. All right, and it was at 25 quarts and grew 2 and 2,500 quarts. So it was at 25 quarts. So it started there. So it'd be 25 plus 2 and 2,500 x. There we go. All right. So these are my two functions. So we graph them. So I went in here and graphed them already on GeoGebra. So again, you see the green line is my whole milk, right? It's my whole milk at 103 minus 3x, and then my bluish purple line right here is my low-fat milk, which I call L of X, 25 plus 2 and 2,500. So we'll give ourselves some more space. So we have our two functions graphed, and then question D says, write an equation that could be used to determine in what year the consumption of whole milk was the same. So we want to know, write an equation for when these two graphs are the same. Well, anytime, so that again, this is my solution right here, where they intersect, but to write an equation where the two functions are the same is write an equation where the two equations just equal one another. So my two expressions equal. So 103 minus 3x equals 25 plus 2,500, 2 and 2,500 x. Okay. So use a graph to solve this equation. So where they intersect, it looks like we're about at 15. So I'd write a solution set saying 15. So basically x equals 15. Okay. Then it says write an inequality that could be used to determine in what years the consumption of whole milk was less than the consumption of low fat. So the years where the whole milk is less than the consumption of low fat. So I come back to the graph and I know that my green line is my whole milk. My blue line here is my low fat milk. So the question is saying determine what years the consumption of whole milk is less than. So the whole milk line right here. So when is this green line less than the blue line? So in our terms, when is it below? Everything above is greater. This is when it's below. So I could say my inequality would read when the blue line, or the 25 plus 2 and 2,500 x, is greater than my green line, which is the 103 minus 3x. So I'd come over here and say when 103 minus 3x is less than 25 plus 2 and 25 hundredths x. Okay, so use the graph to solve this inequality. So it's when everything is greater than 15, because when everything is greater than 15, the low fat consumption was greater than the whole fat or whole milk consumption. So I would say when x is greater than 15 in the solution set. All right, so that's all we have for today. I really want you to, if you have questions, email me. I want you to give the homework a try, and we'll talk about it again. I'm not going to be here tomorrow, so I'll let you know what tomorrow looks like when we know more about what school is going to look like. All right, guys, have a good one.